On September 12, 2013, humanity reached an incredible milestone. The Voyager 1 spacecraft, launched back in 1977, crossed the boundary of the heliosphere and entered interstellar space. It became the first human-made object to leave the realm of the sun's influence. But what seemed like a triumph of engineering thought gradually turned into one of the most mysterious stories of space exploration. Today, Voyager 1 is more than 24 billion kilometers from Earth. This is such an unimaginable distance that a radio signal, traveling at the speed of light, takes 22.5 hours to cover it. Imagine, when engineers send a command from Earth, they have to wait almost 2 full days to receive confirmation. In this abyss of distance, a strange story began. In the spring of 2022, mission operators at NASA's Jet Propulsion Laboratory noticed something unusual. The probe's attitude and control system began transmitting data that made no sense. Telemetry showed that the spacecraft was supposedly rotating chaotically, as if it had lost orientation in space. However, this contradicted other data. The probe's antenna continued to point precisely at Earth, and the signal remained stable. Suzanne Dodd, the Voyager project manager, said a phrase that made many people wary: "It's a mystery. We see that the spacecraft is operating normally, but the system is outputting data that is simply impossible." Engineers faced a paradox. How can a device simultaneously function correctly and transmit meaningless information? To understand the full strangeness of the situation, we need to remember what we're dealing with. Voyager 1 is 1970s technology. Its onboard computer has only 69.5 kilobytes of RAM. For comparison, a modern smartphone exceeds it in computing power by millions of times. But it was this simplicity that made the probe reliable. Fewer complex systems means fewer points of failure. However, age takes its toll. 47 years in space. 47 years of continuous exposure to cosmic radiation, micrometeorites, and extreme temperatures. Electronics gradually degrade. The radioisotope thermoelectric generator powering the probe loses about 4 watts of power every year. Once it generated 470 watts. Now it's less than 250. NASA engineers began a detailed investigation. The first hypothesis was obvious: a malfunction in one of the memory chips. The orientation control system uses several microchips to store data about the spacecraft's position. If one of them was damaged by radiation, it could explain the distorted telemetry. But testing showed the memory was working. Data was being written and read correctly. Then a second version appeared. The problem was in the transmitter. Perhaps the information was being distorted during radio signal formation. Engineers conducted a series of tests, sending commands to switch between backup systems. And here something strange happened. After one of the switches, the meaningless data suddenly stopped. The probe began transmitting normal telemetry again. It seemed the problem was solved. But this was only the first chapter of the story. A few months later, in the fall of 2022, something even more inexplicable began. The probe started periodically going silent. Not completely, the carrier wave continued arriving on Earth, but the modulation containing data disappeared. It was like someone was turning the sound on and off, but leaving the radio running. The periods of silence were irregular. Sometimes the probe would go silent for several hours, sometimes for a day. Then communication would restore itself, without any commands from Earth. Engineers ruled out the influence of space weather. In the area of Voyager's trajectory, no disturbances in the interstellar medium were observed that could interfere with signal transmission. Here it's important to understand the specifics of radio communication at such distances. Voyager's transmitter power is only 23 watts, less than an ordinary light bulb. By the time this signal reaches Earth, its power is about 1/quintillionth of a watt. This is an incredibly weak signal. To receive it, giant 70-meter antennas of the Deep Space Network are used, located in California, Spain, and Australia. With such signal weakness, any external impact could drown it out. But checks showed all ground systems were working perfectly. The antennas received signals from other spacecraft without problems. Atmospheric conditions were favorable. The source of interference was on the probe's side. In the spring of 2023, engineers made a radical decision. They sent a command to reboot Voyager's main computer. This was a risky operation. The probe is so old that no one could guarantee it would turn on again. 45 hours of waiting. The command goes to the probe. Another 45 hours for the signal to return. 3.5 days of tense silence. And the probe responded. The reboot was successful. Moreover, the anomalous behavior stopped. Communication stabilized. NASA officially announced that the problem had been solved through software updates and switching to backup systems. But what exactly caused the failures was never precisely established. This is where things get really interesting. Various theories about the nature of these anomalies appeared in the scientific community. One of the most discussed is related to the impact of the interstellar medium. Voyager 1 became the first object to enter this region of space. We didn't know exactly what awaited it there. The interstellar medium is not a void. It's a rarefied gas, consisting mainly of hydrogen and helium, with a density of about 1 atom per 10 cubic centimeters. Sounds like nothing, but actually it's thousands of times denser than in the interplanetary space of the solar system. In addition, there's the galactic magnetic field and streams of high-energy particles, cosmic rays. Dr. Ed Stone, the longtime Voyager project scientist, suggested perhaps the probe encountered a region of increased concentration of ionized gas. Such plasma could create a local electromagnetic disturbance that affected the electronics. Theoretically, this could cause both false sensor readings and temporary failures in the data transmission system. But this hypothesis has a weak point. Why was the impact so selective? Why did the orientation system suffer specifically, and not other instruments? And why was the effect intermittent rather than constant? A plasma cloud couldn't appear and disappear with such periodicity. Even if the probe was flying through an inhomogeneous region, the nature of the impact should have been different. The second theory concerns accumulated radiation damage. Over almost 50 years in space, Voyager has received a colossal dose of radiation. Cosmic rays are high-energy protons and heavy nuclei moving at nearly the speed of light. When such a particle passes through a microchip, it can change the charge in individual transistors, causing what's called a single-event upset. Usually such upsets are random and scattered. But what if latent defects accumulated in the microchips over decades of irradiation? Microscopic areas of damaged silicon that behave normally most of the time, but under certain conditions, for example, temperature fluctuations, start working incorrectly. This could explain the sporadic nature of the problems. However, there's an inconsistency here too. Engineers ran simulations of radiation impact on identical components in laboratories. Yes, accumulated defects exist. But the pattern of failures that Voyager showed didn't match any of the degradation models. This was something else. A third, more exotic theory involves the influence of unknown dark matter particles. We know that dark matter comprises about 85% of all matter in the universe, but we don't know what it consists of. One hypothesis suggests the existence of WIMPs, weakly interacting massive particles. If they exist, their concentration in interstellar space may be higher than in the vicinity of stars. Theoretically, collision of such a particle with sensitive electronics could cause an anomalous signal. But this is pure speculation. We have no evidence that dark matter can interact with ordinary matter in this way. Moreover, if this were the case, we would observe similar effects in other spacecraft. And we don't. Now let's talk about what really concerns scientists, though it's discussed much less. The problem of timestamps. When Voyager transmits data, each packet of information contains a timestamp, the moment when that data was recorded by the onboard computer. During the anomaly period, some packets contain timestamps that were ahead of real time by several seconds. This may seem insignificant. Big deal, the probe's clock is running fast. But in astronautics, precise time is critically important. Timestamps are used to synchronize data from different instruments, to calculate trajectory, to coordinate maneuvers. If the onboard clock starts lying, it's a fundamental problem. Engineers check the clock generator, the quartz resonator that sets the pace of the computer's operation. It proved to be stable. So where did these anomalous timestamps come from? One explanation, a glitch in the software that forms data packets. Perhaps under certain conditions the code writes an incorrect time value. But this explanation is unsatisfactory because the same software had worked flawlessly for 45 years. There's another detail that few people know about. In October 2023, after the official announcement of the problem's resolution, a brief episode occurred that didn't make it into public reports. The probe transmitted a data packet that contained information that shouldn't have been there. These were readings from a scientific instrument that had been turned off back in 2008. The magnetometer, an instrument for measuring magnetic fields. It was turned off because it consumed too much energy, and the main part of its scientific program had already been completed. The shutdown command was sent, confirmation received. Since then, the magnetometer shouldn't have been generating any data. But in that October 2023 packet, its readings suddenly appeared. And not zero values, not noise. These were meaningful data showing changes in the magnetic field. When engineers saw this, they immediately sent a magnetometer status query. The response showed, the instrument is off. The team checked the entire power circuit. The magnetometer really wasn't receiving electrical power. But where did the data come from then? The official version, a glitch in the telemetry system. Perhaps old data from buffer memory accidentally got into the current packet. But this version raises questions. Buffer memory on Voyager is volatile. It's erased when power is disconnected. Even if some old data remained there, it should have disappeared over 15 years. Some engineers suggested it could be induced electromotive force. A magnetometer is essentially an inductance coil. If the probe was flying through a region with a rapidly changing magnetic field, an induction current could arise in a disconnected instrument, sufficient to generate a signal. But for this, the field would have to change incredibly fast. Much faster than any known processes in the interstellar medium. This episode raised a question that no one wanted to voice aloud. What if Voyager is recording real phenomena whose existence we simply don't know about? What if something is happening there, in interstellar space, that doesn't fit our models? The interstellar medium is terra incognita of modern science. Before the Voyagers were launched, we only had theoretical models. Even now, when Voyager 1 and its twin Voyager 2 have been there for more than 10 years, we have data from only 2 points in a huge space. It's like judging an ocean by 2 bottles of water. What do we actually know? The interstellar medium is inhomogeneous. There are clouds of neutral hydrogen, there are regions of ionized gas. There are magnetic filaments, structures with increased magnetic field intensity, stretching for tens of light years. There are shock waves from ancient supernova explosions, propagating at speeds of hundreds of kilometers per second. And all of this is permeated by cosmic rays, particles with energies we can't reproduce even in the most powerful accelerators. Dr. Jamie Rankin, a physicist from Princeton University studying Voyager data, expressed an interesting thought. She noticed that the anomalies in Voyager 1's operation correlate with moments when the probe crossed presumed boundaries between different regions of the interstellar medium. These aren't exact coincidences, but a statistical connection is visible. Perhaps at the boundaries between regions with different densities and magnetization, turbulent zones exist. Imagine the meeting of 2 air currents in the atmosphere, vortices, ascending and descending flows, zones of increased pressure arise there. Something similar may occur in interstellar space, only instead of air molecules there are ions and magnetic fields. If Voyager entered such turbulent zones, plasma vortices could create local electromagnetic fields that induced interference in electronics. And rapid changes in these fields could induce currents in disconnected instruments. This would explain both the sporadic nature of the problems and the mysterious data from the magnetometer. But this is still a hypothesis. To test it, additional data is needed. Unfortunately, the Voyager's operating time is limited. As already mentioned, their radioisotope generators are losing power. According to current estimates, by about 2030 there won't be enough energy to maintain communication with Earth. We have about 6 years left to get the last data from them. NASA plans to gradually turn off instruments to extend the operation of the main communication systems. Heaters for some instruments have already been turned off. Soon they'll have to turn off the last working scientific instruments. Eventually Voyager will turn into a simple radio beacon, transmitting only basic telemetry. And then silence will come. The probe will continue its flight through the galaxy, but will no longer know what it encounters on its path. In 40,000 years it will fly at a distance of 1.5 light years from the star Gliese 445 in the constellation Camelopardalis. Another 240,000 years later it will approach the star Sirius. And in 5 billion years, when our sun turns into a red giant, Voyager will still be wandering in the darkness between the stars. It carries a golden record, a message from humanity to any intelligent beings who might find it. It contains Earth sounds, images, music, greetings in 55 languages. It's a time capsule, a monument to a civilization that dared to look beyond its home. But let's return to the mysteries. There's another aspect of the Voyager story that isn't customary to discuss in official reports. It concerns how engineers react to anomalies. In the space program, there's a strict protocol. Any unusual behavior of the spacecraft is documented, analyzed, goes through multiple levels of verification. But sometimes things happen that are so strange they don't even know how to classify them. One of the engineers who worked with Voyager, let's just call him Robert, told an interesting story in a private conversation. This was at the end of 2022, at the height of the Anomaly period. Night shift at the control center. Robert was monitoring incoming telemetry when he noticed a brief spike in one of the data transmission channels. The spike lasted less than a second. Spectrum analyzers recorded it, but automatic systems didn't raise an alarm because the signal didn't match any known types of interference. Robert decided to study the recording in more detail. When he decomposed the signal into a spectrogram, he saw something unusual, a clear structure, a repeating pattern. This wasn't noise. Noise is random, chaotic. This was modulation carrying some information. Robert tried to decode it using various algorithms. Nothing fit. It didn't correspond to any of the data transmission protocols used by Voyager. He turned to a colleague, showed the recording. He couldn't explain it either. In the morning, Robert reported the finding to management. An instruction followed: archive the data for further analysis and continue observation. Analysis was conducted. The conclusion was diplomatic. Transient process of undetermined nature, possibly related to plasma effects in the propagation channel. In other words, we don't know what this is, but let's consider it interference. Similar episodes occurred several more times. Always brief, always with this strange structure in the signal. Some engineers began joking that Voyager is trying to tell something important, but we don't understand its language. Jokes aside, the question remained: where did this modulation come from? There's a phenomenon called plasma instability. When a radio wave passes through ionized gas, it can interact with plasma oscillations, generating secondary waves. This creates complex interference patterns. Theoretically, this could generate a structure similar to modulation. But this requires very specific conditions: a certain plasma density, a certain wave frequency, a certain magnetic field. The possibility that all these conditions randomly coincided several times at different times is extremely small. But alternative explanations don't look any better. Could this be interference from terrestrial sources? Unlikely. The frequency on which Voyager operates is protected by international agreements. Powerful transmitters at this frequency are prohibited. And the signal's nature didn't match ground interference. Could this be radiation from some astronomical source? A pulsar, magnetar, active galactic nucleus? Also no. First, the signal's direction of arrival coincided with Voyager's direction. Second, astronomical sources have different radiation characteristics. Their signals are either regular, like pulsars, or chaotic, like flares. This was something else. The most uncomfortable possibility remains: a source on board the probe. But what on Voyager could generate such modulation? All transmitters operate at strictly defined frequencies with strictly defined modulation algorithms. There are no unaccounted generators there. Unless some nonlinear effects arose in the electronics, turning it into an unintentional signal generator. Radiation-damaged semiconductor junctions sometimes behave as detectors or frequency mixers. They can modulate signals in unpredictable ways. Perhaps some component in the transmitter circuit degraded to such a state. This version was reassuring but not fully convincing. Nonlinear effects should manifest constantly, not episodically. And they should depend on temperature, current consumption, and other parameters. But no correlation with these parameters was found. In any case, these mysterious bursts stopped after the same software update that eliminated the main problems. Since the beginning of 2024, Voyager 1 has been operating stably. Telemetry is normal, communication is steady. Scientific instruments transmit data about the interstellar medium. Everything has returned to the routine of a long space mission. But a residue of uncertainty remains. Was this really just a series of hardware failures? Or did the probe encounter something we don't yet understand? Interstellar space is full of surprises. Voyager 1 has already presented us with several. It discovered that the heliosphere boundary is farther than assumed. It showed that the interstellar medium is denser and more active than thought. It recorded tsunamis in interstellar plasma, shock waves from solar flares reaching the boundaries of the solar system. Each of these discoveries forced textbooks to be rewritten. So maybe the anomalies of 2022 to 23 are also data that we don't yet know how to interpret. Maybe in 10 or 20 years, when we learn more about the interstellar medium, we'll return to those archival recordings and say, there it is. That's what the probe was trying to show us. A new generation of interstellar missions is now being prepared. The interstellar probe concept involves launching a probe that will reach a distance of 1,000 astronomical units in just 50 years. That's 10 times farther than Voyager traveled in its journey. On board will be modern instruments capable of studying the structure of the interstellar medium in detail. Perhaps they will shed light on the mysteries the Voyagers encountered. But so far these missions exist only on paper. Funding isn't approved, technologies are still being developed. Launch, if it happens, won't be before the late 2030s. And Voyager 1 is already there, already now. It's our only active messenger in interstellar space. And here's another thought that makes you think. Voyager 1 is moving at 17 kilometers per second relative to the Sun. This seems incredibly fast, 61,000 kilometers per hour. But on the scale of the galaxy, this is a snail's pace. The nearest star, Proxima Centauri, is 4.25 light-years away. At its current speed, Voyager would need 73,000 years to reach it. If it were flying in that direction, which it actually isn't. During this time, 3,000 generations of people will change on Earth. Civilization may change beyond recognition. Or disappear. And the probe will still be flying in a void, a silent witness to an era when humanity was just beginning to explore space. It carries that golden record with recordings. A pulsar map indicating the Sun's position. Images of people, animals, plants. Music by Bach, Beethoven, Chuck Berry. A photograph of a mother with a child. All of this is protected by a gold coating designed for billions of years. Even when the electronics are long destroyed, when the probe's body turns into debris, the record may survive. Carl Sagan, one of the ideological inspirers of the Voyager project, called this record a bottle thrown into the cosmic ocean. He understood that the chance of someone finding it is vanishingly small. But the very fact of its existence is important to us. It's an assertion that we were here, that we tried to reach for the stars. Voyager 1's anomalies reminded us of the fragility of this message. Technology ages. communication can be interrupted at any moment. And then the probe will become just a piece of metal drifting in infinity. But while it's still with us, while we still hear its weak signal, we have a unique opportunity to listen to a voice from beyond the edge of our world. So what ultimately caused the strangeness in the probe's behavior? NASA's official version is a combination of hardware failures related to aging electronics and the impact of the interstellar medium. This is a reasonable, conservative explanation based on known physical processes. Most likely, it's correct. But science isn't only about what we know. It's also about what we don't know. And the Voyager story shows how much remains unexplored. Interstellar space, this vast area between the stars, is still a mystery. We've only begun to explore it. Only begun to understand its complexity. Perhaps the most important lesson of this story isn't in specific technical details, but in the fact that reality is always richer than our models. We build theories, make predictions, but nature constantly presents surprises. Sometimes these surprises change our understanding of the world. Sometimes they remain mysteries for years until new data or new ideas appear. Voyager 1 continues its journey. Every second it moves 17 kilometers away from us. Every day it opens a new area of space where human-made objects have never been before. And who knows what other surprises awaited ahead. Maybe we'll hear another strange story before the final silence comes. Or maybe everything will be quiet and calm until the very end. But even if there are no more anomalies, even if the remaining years of the mission pass without incidents, Voyager has already taken its place in history. Not only as a technological achievement, not only as a source of scientific data, but also as a symbol. A symbol of humanity's desire to go beyond the known. A symbol of hope that somewhere out there, in the expanses of the galaxy, we're not alone. Or, even if alone, that our existence has significance sufficient to leave a trace among the stars. In decades, when the last signal from Voyager fades, when the giant deep space network antennas catch only the noise of the cold universe, the probe will become humanity's true messenger. Silent, invisible, but carrying the memory of a civilization that once looked at the sky and dreamed.